The first presentation is Mental Imagery and Imaging Mental Disorders, Implications for Psychological Treatment by Professor Emily Holmes, who is Programme Leader at the MRC Cognition and Brain Sciences Unit at the University of Cambridge. Please give her a warm welcome. Thank you.
Thank you, Natasha. And thank you very much to Brain Forum. It's such a pleasure to be at this extremely interesting meeting, have discussions with such a diverse range of scientists, and also to be in this beautiful city of Lausanne. I'm a clinical psychologist. That means that I treat my patients through talking to them, and we treat a range of disorders. I'm going to focus on post-traumatic stress disorder today. I'm also a cognitive neuroscientist, and I'm interested in the science of mental life and how that can underpin our treatments of the future. And I'm going to talk to you about why I think psychological treatments are a really important part of the puzzle when it comes to improving mental health. And Brain Forum is a wonderful forum for doing just that, because if we can understand mental disorder, it gives us a wonderful way in to understanding mental order or function. As Steve Hyman said this morning, our processes are on a continuum from function to dysfunction. We don't have completely separate types of brains. And by studying mental disorder, the great prize at the end of that day is also to improve our treatments. And why do we need to do that? Well, the scale of mental health and mental disorders, unfortunately, is huge. So the bad news is that approximately 1 in 4 people at some point during their lifetime will suffer a mental disorder. That means that for most of us, someone in our family is going to be affected. And there's a wide, fascinating range of mental disorders, from depression that we'll hear more about today, and anxiety disorder, fear of the future, through to more chronic conditions that I also work with, bipolar disorder and schizophrenia. What we know now is that almost half of diagnosable cases will begin by the time someone's a child or in their youth. And the impact on our society is enormous. In Europe, the biggest killer of young people at the moment is not road traffic accidents, not physical health, it's suicide. And the cost of people being unwell is huge. There's just a statistic here in terms of sick leave. So if it's as big as I've been saying, if the scale is so big, it's going to affect so many people, why don't we see more of it? Well, the great title of the symposium today is concerning stigma. And I guess the interesting thing about mental disorders is quite how invisible they can be. Our family members might not even talk about it with us. Our colleagues are reluctant to tell us about it. And my patients have very often made a very brave journey to come and tell me the first time they come into my office. So stigma is something that we need to take on the chin and tackle, just as in the past it's been done for cancer or HIV or any other kind of physical illness. In fact, in the name of the aim of the research charity MQ, which Sophie Dix spoke about yesterday, I really like this aim that they state, which is mental health should be as respected as physical health and understood, diagnosed and treated just like any other disorder. Now, the invisibility goes with a big problem. There's been a huge lack of funding, a scandalous lack of funding. And that's very important. And if you think about the relation to physical health, we've made great strides in improving physical disorders, but we really need to improve treatments for mental health disorders. But I guess as scientists, it also gives us a really exciting opportunity to forge careers where science is so very, very much needed in the years to come, and to tackle puzzles that are really fascinating and are going to be breaking frontiers to go forward. So let's think a little bit. What do we really mean by mental disorder? The Diagnostic Handbook would describe it as a syndrome characterized by significant disturbance in cognition, the way I think, emotion, and behavior, action, which reflects a dysfunction of underlying processes. And this is a picture of Switzerland. What this means is that these processes, which occur in a continuum, just as we had the analogy of blood pressure earlier, throughout populations, give us a wonderful bridge to cross between the science we're learning about in neuroscience and its application to clinical treatments. But this bridge needs to be made stronger than this little tiny rope bridge. Actually, I think that looks really frightening to go across. But we need a strong bridge that can really unite communities and take better strides. So, as I mentioned, I'm really interested in psychological treatments. For many neuroscientists, psychological treatments conjure up ideas of people lying on a couch. It's not just about lying on couches anymore. Psychological treatments have a strong evidence base for many disorders now, and the evidence-based treatments that are shown to be effective are typically those where there's a very detailed manual, a protocol of what we do, a protocol of what we're targeting. We might be targeting dysfunctional behaviors, dysfunctional cognition, emotion regulation, habits, all processes core to a better understanding required from brain science. But how do these treatments work? So, for example, in the area of PTSD, post-traumatic stress disorder, the best treatments we currently have for our patients is not a pharmacological one. It happens to be one where we have to focus on the memory of the trauma using techniques called exposure and trying to, as it were, update that memory and put it to rest. How can this happen? How can we understand where we have an effective treatment, what mechanisms are underlying that? And Helen Mayberg's work is a wonderful example of starting to do that. So with colleagues, we've called for a vision to really try understanding the mechanisms, and by understanding common mechanisms, generate new and more effective treatments, and to do so in conjunction by talking to laboratory and clinical researchers. And the word mechanisms has been bandied a lot at this conference. And I guess I really want to emphasize mechanism is something that would cause a causal change in the system. So that could be at a molecular level, as Julio pointed out yesterday, all the way down through circuitry, through cognition, through behavior, or as Andreas will talk about later, social factors. We need all types of mechanism, and we'll need all types of treatments to answer the scale of the problem. So let me give you a glimpse of something that we find really interesting and an exciting area to look at. So post-traumatic stress disorder occurs after someone's had a traumatic event. That could happen to any of us, a car crash, surgery. And after that event, images, so scenes, visual pictures of that event spring to mind, not when someone chooses them, but when they don't want to have them. So I could be trying to talk with you now, but suddenly memories are coming back when I don't want them to. These memories can last milliseconds initially, but they are very, very distressing, and they're worse when clinical, can persist for years. So someone with war experiences may have visual, vivid memories of seeing a bomb go off. Somebody who's undergone a surgery that has gone wrong may have vivid visual images of a surgical procedure or the lights in the hospital. And somebody who has undergone traumatic childbirth, that's a situation where either the mother or the child's life was at risk, may have haunting images of scenes from within that childbirth. So these are things that can happen to all of us. Now, what do brains tell us about these images? So mental images are really interesting. They're, as it were, a form of activation in the visual cortex. And I've represented that there, where you can see the eye. So visual cortex is, as it were, representing, like weak perception, the event happening again. So it's the representation of sensory information of the absence of that percept and coming again and again. So we might want to ask fundamental questions, like is post-traumatic distress simply to do with social factors after trauma? We don't think so. Our brain data, using the kinds of paradigms that Jack Gallant was talking about earlier, show if we scan people whilst viewing traumatic movie footage, moments within that trauma scenes, like the clips that he showed with different sections, we have different sections of trauma. We can tell from the very time of them people viewing trauma which moments are going to become intrusive and which don't, and they differ in their pattern of neural activation. And we can also apply statistical techniques such as MVPA to this data, and for a given patient predict with a high degree of accuracy which scene is going to become an intrusive trauma memory before that patient's even had that scene. So I think this is really interesting, because if the brain data is telling us that even at the time of viewing trauma, our brain's setting up, as it were, a mental scar to that later reaction, it suggests that we should be doing something early to stop this process from going awry. And in physical medicine, if our child is bitten by a dog, you would get a rabies vaccine. If a child has a trauma, we currently have no vaccines to give it or to protect against effects, because we only diagnose PTSD a month later and early treatments are lacking. So one idea coming from brain science I'd like to just raise is the idea, could we use quite simple techniques to help stop these visual memories becoming so vivid and intrusive that it would haunt that person for many years to come? How would we do this? Well, the hypothesis we've been working on for many years now is the idea that if it is one part of the trauma memory is the fact it's so visual and vivid and intrusive, then we can target activity in visual cortex. And if we do that at the time when memories are labile, so whilst a memory is still being cemented to mind, what we would call a memory consolidation time period, that will give us a way to dampen down the vividness of that memory and therefore stop it intruding when people don't want it to. In terms of mechanisms, the tool I would choose here is something that I know is really going to activate visual cortex. And so you could do that in many ways. But one way you can do it is to get people to engage in a cognitive task which is highly visual and spatial and colorful. Here, an example of a particular computer game. But they need to do it on a particular behavioral schedule, and they need to do it in a very specific time window. So our laboratory studies indicate that by doing these kind of behavioral procedures soon after viewing or being exposed to trauma, we can reduce the number of intrusive images and memories of that trauma by about half. Where I would like to go over the next 10 years is to move that into the real world. And here with collaborators in Lausanne, Antje Horsch, for example, working at CHUV, we've been using this model, but actually with women in the recovery room after they've been recovering from traumatic childbirth. So this, and what the women learn to do is to do this activity actually within 6 hours of the traumatic experience. But the scale of traumatic events is not just within our hospitals, it's now huge worldwide. The refugee crisis that is currently happening from war is just one simple reminder of that. So we so need to develop our treatments, we so need to find preventative ones to stop these symptoms building up, I think particularly for children and young people. And maybe we could imagine a day where mental health is given equal research priority and clinical priority to physical health. We can prevent the build-up of symptoms and use this wonderful brain science we're seeing at this conference to help us as clinicians work more like cognitive surgeons, to work with the memories that are problematic and bring relief for our patients. Mental health needs science, so thank you very much for inviting us, and I look forward to discussing later. Thank you to my team.